Water fell in slow, regular drops from the ceiling, striking the stone with a hollow, metronomic sound. The tunnel ran straight into the mountain, its walls rough-hewn and slick with condensation. The granite dark and glistening under thin films of moisture. The air was cold and heavy, tasting of dust and oil. A line of bare tungsten bulbs hung from a cable strung along the ceiling, each bulb caged in a wire guard, their yellow light flickering against the wet stone. Shadows clung to the recesses where the rock had fractured. Far behind, somewhere near the entrance, the muffled rumble of trucks filtered through the rock, then faded as the tunnel went deeper. Under boots, the floor was compacted gravel set into poured concrete, worn smooth by wheels and footsteps. Black electrical cables ran in parallel along one side, held by rusting clamps, their rubber sheathing beaded with droplets. Every few meters, rust-brown streaks marked places where iron supports met water. The temperature hovered just above freezing, the breath of the men in the passage forming thin bursts of white that vanished almost as soon as they appeared. The corridor bent sharply to the left. Beyond the bend, the ceiling rose and flattened, the raw rock giving way to reinforced concrete. Steel I-beams formed a hidden skeleton behind the gray surface. On the floor, a darker strip of embedded rail, twin lines of narrow gauge track, glinted under the lamps, peppered with specks of grease. A pair of soldiers in field-gray greatcoats stood beside a heavy steel door, recessed into the wall, carbines slung, collars turned up against the cold. Their helmets reflected the nearest light bulb in small, pale crescents. The door itself was painted matte black, edges polished by repeated opening and closing. Two locking bars crossed its surface, secured by a central wheel with 4 spokes. Above it, stenciled in white, were only numbers and letters, barely visible in the dimness. A narrow inspection slit sat at eye level, closed. The metal smelled faintly of oil and hands. When the wheel turned, the vibration ran through the frame and into the concrete. The locking bars slid back with a dull mechanical scrape. Hinges exhaled a short grinding noise that echoed down the tunnel. Beyond the threshold, another passage opened, wider now, with the ceiling rising still higher. The sound changed, too. The hard reflections of footsteps softened into a deeper, more cavernous resonance. Somewhere ahead, fans hummed steadily, adding a low, continuous undertone. This inner corridor was lined with conduit. Thick pipes, insulated with rough textured lagging, ran along both walls, brackets sinking into the concrete at exact intervals. Valves glinted under the lamps, each marked with small, precise numbers stamped into metal tags. Narrow ducts carried air, their welded seams catching the light. Every few steps, a red-painted emergency switch protruded from the wall, protected by a wire cage. The odor of the air shifted to something more mechanical, a mixture of hot oil, cold metal, and the faint, sour bite of ozone. The passage opened at last into a high chamber carved deep beneath the Bavarian Alps. The walls here were no longer raw rock, but layered concrete, the seams between pores forming horizontal shadow lines. Overhead, steel trusses crisscrossed in rigid geometry, painted a dull industrial green that was almost black in the weak light. The ceiling disappeared into shadow beyond the range of the lamps, but the heavy presence of the mountain above was palpable, pressing down in weight and silence. Along one side of the chamber, panels crowded together, slate-gray control cabinets, with metal handles, arrays of analog gauges under glass, rows of ceramic switches. Each panel bore a neat designation in black lettering on a white enamel plate. Cables emerged from their bases and vanished into trenches cut into the floor, covered by removable steel grates. Indicator lamps glowed faint red and amber, tiny islands of color on the otherwise monochrome surface. The faint tick of relay contacts rose and fell sporadically, almost lost beneath the deeper hum of distant generators. On the opposite side, thick coolant pipes climbed toward the ceiling before bending and disappearing through armored penetrations. Frost formed along parts of their length, thin crystals spreading outward from weld seams, catching the light in granular sparkles. Drops of condensed moisture fell at irregular intervals, leaving tiny circles on the floor where they struck the bare concrete. A network of catwalks and grated platforms clung to the walls, connected by steep metal stairs. Footsteps on the steel rang out sharp and hollow, then were quickly swallowed by the volume of the room. At the far end of the hall, the concrete floor rose smoothly into a broad circular plinth set flush with the ground. Its surface was darker than the surrounding floor, polished by countless boots and traced with hairline cracks. Painted onto the concrete, centered on this raised ring, was a symbol, a black sunwheel, composed of 12 radial segments arranged in a circle, each spoke tapering inward but not quite meeting at the center. The paint was thick, its edges crisp, the matte black absorbing the dim light. Around it, the concrete bore faint scuff marks and the ghostly arcs of dragged equipment. Above the emblem, anchored to the plinth by massive steel supports, stood the machine. It dominated the chamber, a great toroidal body of dull metallic sheen, nearly 4 meters across, suspended horizontally on 12 radial arms that matched the underlying pattern on the floor. Each arm was a lattice of steel, bolted into the plinth and rising to meet the outer ring at precise intervals. The ring itself was layered, an inner band of smooth, light-colored metal, a middle band ribbed with shallow grooves in which narrow copper coils were wound, and an outer shell of darker alloy, broken by access hatches sealed with hexagonal bolts. Power conduits, as thick as a man's arm, entered the torus from beneath, bending upward in tight arcs, before plugging into junction boxes along its circumference. Smaller lines, instrument cables, coolant feeds, vacuum lines, ran alongside, bundled in disciplined order, held by metal clamps at regular intervals. Near the top of the ring, a narrow slit traced most of its circumference, covered by a transparent pane that looked almost black under the lamps. Behind that curved window, something faintly reflective caught the light and sent back a muted glow, like glass seen underwater. Around the plinth, men moved with deliberate, economical motions. Engineers in dark overalls stood by the control racks, pencils poised over clipboards, eyes shifting between gauges and the black sun emblem beneath the machine. SS officers in tailored uniforms watched from the shadows near the walls, their boots shining under the thin light, the silver of their insignia flat and cold. The air in the chamber hung still, broken only by the distant throb of heavy machinery somewhere. Deeper in the complex, and the rasp of filtered air passing through high-mounted ducts. Near the base of the reactor, a radiator grill exhaled a slow breath of warm air, forming small distortions in the light as it rose, and mingled with the colder air above. Somewhere inside the torus, unseen, pumps whirred softly, sending vibration through the structure. It was barely audible, more a sensation underfoot, a faint, persistent tremor, like the mountain itself had begun to hum. The concrete transmitted the vibration to the soles of boots, to the metal frames of the catwalks, to the bodies of the men watching. Above the machine, a crane track curved along the ceiling, its hoist idle, chains hanging straight down, unmoving. Dust motes drifted in the light, their slow motion betraying the stillness of the air. On the far wall, a large clock with black hands and a white face measured the seconds with mechanical precision, the subtle movement of its thin second hand marking time over the motionless black sun painted on the floor. No explanation was written on the walls. No plaques named the machine. Only the emblem, the cables, the quiet, and the gathering of steel and concrete beneath the mountain. The men guarding it called it many things in private, but in the documents that survived, it had one designation. It was the Black Sun Reactor. Its origins lay far above the mountain chambers, in offices and institutes scattered across the Reich, years before the first tunnel had been cut into the slope. In the late 1930s, as the foundations of war were laid in treaties and violations, another foundation was forming inside Germany's scientific community. It was the Uranverein, the Uranium Club, a loose gathering of physicists investigating the potential of nuclear fission under the direction of the Army Ordnance Office. Names from lecture halls and journals suddenly acquired military relevance. Heisenberg, Diebner, Bopp, Gerlach. Early experiments with uranium and moderated neutron flux suggested the possibility of a sustained reaction. The conventional goal was clear: a reactor that could generate power or produce fissile material for weapons. But parallel to these official efforts, other currents moved through the Reich. Within the SS, and particularly within Heinrich Himmler's personal domain, the Ahnenerbe, the Ancestral Heritage Research and a Teaching Society, blended archaeological fantasy, racial ideology, and selective science into a separate framework of projects. Under its umbrella, and later under the expanding authority of SS Obergruppenführer Hans Kammler, certain concepts from nuclear physics and high-energy research were filtered into more esoteric proposals. One of these proposals, emerging at the intersection of SS Ahnenerbe, the Reichs, nuclear research, and experimental energy systems, concerned a reactor that would not only convert mass to heat through controlled fission, but would also exploit rotational and electromagnetic phenomena to generate fields of unusual intensity. It was not merely to be a power source. It was to be a field machine, a reactor that used nuclear energy to sustain a toroidal plasma and, through magnetic resonance and ion field containment, produce effects beyond pure thermal output. The conceptual groundwork was laid in memoranda circulated in 1941 between SS physicist working groups and engineers connected with Siemens and AEG. Reports discussed toroidal geometries, closed magnetic loops, and the possibility of sustaining a rotating ion current within a vacuum chamber. Borrowing from emerging theories of plasma confinement and the behavior of charged particles in magnetic fields, the design sketched a device in which nuclear-derived heat would ionize a working medium and drive a continuous toroidal discharge. In turn, that discharge could be shaped by external coils to generate intense directional fields, potentially useful for advanced propulsion, high-energy research, or, in speculative annexes, for influencing the propagation of electromagnetic waves and charged particle streams. Because such a reactor would require materials, manpower, and secrecy beyond civilian institutions, it was absorbed into the SS framework. Funding flowed not through the nominal channels of the Uranverein, but through hidden accounts linked to the Ahnenerbe and Himmler's personal budget. To disguise its nature, the project was assigned an innocuous cover designation related to Alpine hydropower development. In internal SS correspondence, however, it acquired another name, one tied to the symbol Himmler had installed in the floor of the north tower of Wolfsburg Castle, the Black Sun. The symbol, a sunwheel of radial spokes, was repurposed as the project's internal emblem. The reactor's toroidal shape, with its encircling coils and radial supports, would mirror the sunwheel geometry. Officially, its code name became Sonnenrad, sunwheel, and in some documents, Sonnenreactor B. In field reports and whispered conversations in the tunnels under the Alps, it was simpler, the Black Sun Reactor. Kammler's growing empire of special projects needed secure locations. As Allied bombing intensified and the vulnerability of surface facilities became obvious, attention shifted to the mountains. The Bavarian Alps offered rock, elevation, and proximity to power centers of the regime. The Obersalzberg complex, the Berghof, and associated bunkers. Geological surveys conducted ostensibly for new air raid shelters doubled as site searches for deep installations. One such survey, led by an Ahnenerbe geologist, identified a massif above a narrow valley where the rock was compact, dry, and stable. Beneath its slopes, a labyrinth of tunnels and chambers could be carved, shielded by hundreds of meters of stone. Construction began in late 1942 under Organization Todt. Forced labor was brought from Dachau subcamps, marched up the forest roads under guard, and driven into the rock with drills, explosives, and hand tools. The first tunnel was cut horizontally into the mountain, then branched and widened into a central hall from which other galleries radiated. Concrete followed, poured over steel reinforcement to create smooth-surfaced rooms within the rough stone. Ventilation shafts were bored upward and disguised above ground as harmless agricultural or forestry structures. At the same time, in factories across the Reich, components for an unusual reactor were manufactured in isolation from one another. Siemens and AEG facilities produced heavy copper windings and high-current switchgear. A precision engineering firm in Saxony machined segments of a toroidal vacuum chamber from high-nickel alloy. Ceramic plants fabricated insulating supports and moderator elements with beryllium-doped ceramics. Telefunken worked on high-frequency generators capable of driving resonant magnetic fields in the megahertz range. Each part was labeled for delivery to a mountain power station in Bavaria, nothing more. By mid-1943, the central hall at the chosen site was ready. Its floor, ringed with anchor points, awaited the toroidal shell and its supports. Into this hall, under cover of night and under SS guard, convoys brought crates marked only with internal codes. Cranes lowered the curved vacuum segments onto jigs, where teams of engineers aligned and bolted them into a complete ring. Seams were welded, ground, and inspected under X-ray. The inner surface of the torus was polished to a mirror finish. Flanges for diagnostic ports and feed-throughs were added at calculated positions. Around the vacuum vessel, technicians wound copper coils in layers, forming a series of poloidal and toroidal windings, designed to produce a closed magnetic cage. Separate coil sets provided vertical field correction, allowing fine control of the plasma's position once the reactor was in operation. The arrangement drew upon theoretical work only partially understood, extrapolating from particle beam behavior in cyclotrons and early fusion speculation. Yet the guiding principle was clear: to keep a ring of ionized gas suspended within the torus without letting it touch the walls. The nuclear portion of the device occupied the core of the system. Instead of the familiar lattice of vertical fuel rods in a water tank, the Black Sun design placed fuel elements in an annular array around the torus. Uranium oxide, partially enriched and mixed with thorium to enhance breeding, was encased within sintered ceramic elements arranged in a polygonal ring surrounding the vacuum chamber. Between them, a network of cooling channels allowed heavy water to flow, moderating neutrons and carrying heat away. The heat, in turn, drove a secondary working fluid system, superheating a low-density gas injected into the evacuated torus through fast-acting valves. Under the combined influence of temperature and electromagnetic fields, this gas, seeded with ionizable alkali metals, would form a plasma ring, circulating at high velocity. Around this structure, shielding was layered. Inner shells of specialized concrete, loaded with barytes and hematite, absorbed radiation. Outermost, a combination of water tanks and steel plates provided additional protection. The entire assembly rested on vibration-damped mounts anchored into the plinth, isolating the reactor from the mountain and the mountain from the reactor. It was an engineering hybrid, part fission reactor, part experimental plasma machine. Its planned outputs went beyond electrical power. Researchers envisioned dense, rotating fields encircling the core, magnetic, electric, and perhaps others less defined. Memoranda speculated about regional Feldverdichtungen, regional field condensations, which might alter the behavior of charged particles passing nearby. In some annexes, diagrams hinted at possible military uses, deflecting incoming projectiles, interfering with radio waves, or powering advanced propulsion concepts then confined to paper. The secrecy was absolute. The SS garrison at the site answered directly to Kamler. Access to the lower levels was tightly controlled, even within the complex. Only a small inner circle held full clearance. Many of the civilian engineers were nominally attached to innocuous projects and given cover stories. The emblem of the Black Sun, painted on concrete and included on some internal documents, never appeared in official registers. By late 1943, the Black Sun reactor was mechanically complete. Systems testing began with conventional power runs. The coolant circuit was pressurized, flushed, and cooled. Heavy water produced under great expense, some from Norwegian stocks, some synthesized at German plants, filled the moderator channels. Resistance checks verified the continuity of the coils. High-voltage tests crackled within the hall, the sound of discharge echoing off the concrete as engineers probed for insulation flaws. Initial criticality experiments were cautious. Small quantities of fuel were loaded, and control rods, cadmium and hafnium inserts, were adjusted to allow a trickle of neutron flux. Detectors recorded the gradual rise in activity, curves traced carefully by pen recorders. The reactor behaved like any experimental pile at this stage, slow, predictable, responsive to adjustments. The hall remained cool, the air still. It was when the nuclear section reached sustained low-level operation that the distinctive character of the machine emerged. The heat, absorbed by the secondary gas circuits, allowed the operators to feed energy into the toroidal vacuum chamber. With pressures a fraction of atmospheric and controlled injections of working gas, they ignited the first glows. Observers standing at the viewing ports in the control gallery saw, through the darkened glass of the torus slit, a dim ring of violet light form and wrap around the inner circumference. Instruments registered the presence of charged particles confined by the fields. Adjustments to the coil currents sharpened the ring, pulling it away from the inner wall, suspending it in a narrow band. As the field strength increased, the magnetic confinement improved. The ring brightened, small fluctuations dancing along its arc. That was when the first anomalies appeared. Compasses placed on desks in the control room began to deviate, their needles slowly drifting away from true north, even when no current change was commanded. Magnetic sensors detected localized field variations not entirely accounted for by coil currents. In adjacent tunnels, magnetometers used to survey the rock for expansion projects registered transient spikes, rising and falling in time with reactor pulses. Electrical noise invaded wiring not directly connected to the reactor. Static hissed in headphones in the communications room. Oscilloscopes monitoring unrelated experiments in a surface building showed unexplained interference bands whenever the black sun ran at higher field levels. Physiological reports, filed quietly and outside the main test logs, noted headaches among some personnel working close to the reactor hall, a sensation of pressure behind the eyes and fleeting vertigo as if the floor shifted imperceptibly underfoot. These symptoms diminished when field strengths were reduced. The investigators within the SS Technical Administration did not see these as reasons to stop. Rather, they treated them as evidence that the machine was achieving unprecedented field intensities. Additional funds were authorized. Experimental plans were revised to explore operating regimes further from conventional reactor practice. In early 1944, as the front lines moved against Germany and the Allied bombing campaign edged south, operations intensified in the mountain. The Black Sun reactor entered a sequence of structured experiments. Some focused on power generation, others on field effects. During power-focused runs, the reactor operated as a hybrid system. Nuclear heat drove turbines in a separate cavern, producing electrical power that was partially routed back to feed the coils and partially used to supply other underground installations. At modest levels, the system functioned as a compact, concealed power station, less vulnerable to air attack than conventional plants. Yet the majority of test time was reserved for the more speculative phase, high field operation, with the toroidal plasma sustained at the limits of containment. At those times, the hall changed. The lighting dimmed as power was diverted. The hum of transformers deepened in pitch. Cooling water roared more loudly through pipes. Inside the torus, the ring of light brightened to a hard electric blue, then intensified toward white near its inner edge. Photographic plates exposed during these runs showed not only the luminous band but faint, radial streaks extending inward and outward, suggesting that some particles were escaping confinement along lines not predicted by the coil geometry. On one occasion, a blackout of nearby civilian power lines coincided with a peak field test though no direct connection could be proven. The town in the valley below reported flickering lamps and the failure of certain telephone circuits. Within the mountain, the reactor's control systems remained stable, drawing primarily on dedicated generators. Even so, the incident prompted concerns within the Reichspost technical office about interference with the national grid. What the physicists found most striking were measurements taken with the cloud chambers and neutron detectors stationed in adjacent rooms. When the black sun ran at high field strengths, cosmic ray flux readings inside the mountain shifted measurably. It appeared as if the intense fields were modifying the trajectories of high-energy particles, passing through the region, focusing or scattering them in patterns difficult to interpret. Some took this as confirmation that the machine had become not just an internal reactor, but a node interacting with wider fields permeating space. Those conclusions remained tentative, recorded in cautious language. Yet in margins and private notes, words appeared hinting at Schnittstellen, interfaces between the reactor's local fields and larger structures of the geomagnetic environment. The military, however, demanded practical applications. Kamler's network forwarded queries asking whether the field effects could be intensified and shaped. Could the reactor's output be coupled to directed beams, to interference generators, to experimental propulsion drives? Could it power aircraft capable of extreme endurance, submarines immune to conventional detection, or high-energy weapons? The engineers replied with caveats. The system was still barely stable. The interplay between nuclear core and plasma torus was complex, narrow. Margins separated controlled operation from quench or runaway. One miscalculation could lead to a breakdown of confinement, with the plasma contacting the walls and damaging the reactor, or to an uncontrolled power surge in the core. Even so, experiments were scheduled to push the machine further. One high-risk sequence, conducted in the summer of 1944, attempted to synchronize oscillating magnetic field patterns with the natural Schumann resonances of the Earth's atmosphere. Using variable frequency drives on auxiliary coils, the operators modulated the confinement fields at low Hertz range frequencies, while the plasma ring circulated at radio frequencies. For brief intervals, geomagnetic instrumentation both within and outside the mountain recorded unusual fluctuations. The data were fragmentary, but enough to suggest that the black sun had become a participant in a broader, planet-scale electromagnetic system. At the human scale, the effects remained subtle but unsettling. Watches ran a fraction slow after long shifts near the reactor, though. The deviations lay within the tolerated error for mechanical movements. Low-level buzzing sounds, like distant insects, were reported in corridors during high-power operation, apparently emanating from vibrating metal fixtures responding to the time-varying fields. Some fluorescent lamps flickered even when disconnected from power, their gas excited by ambient radiation. The project's secrecy deepened as these phenomena accumulated. SS medics monitored personnel quietly. Replacements were rotated in when symptoms persisted. Documentation grew more compartmentalized, with certain logs kept in separate safes, accessible only to a small core. Above ground, the war turned sharply against Germany. The Allied landings in Normandy, the Soviet advances in the east, and the gradual constriction of remaining territory altered the context of every special project. Yet within the mountain, under rock and concrete, the black sun continued to run. its internal pulse indifferent to the shifting front lines. By late 1944, however, the encroaching front could not be ignored. The Bavarian Alps lay far from immediate combat, but they stood within reach of Allied reconnaissance and future ground thrusts. Kammler, tasked with preserving or denying the Reich's advanced technology, began issuing directives for relocation or destruction. Projects that could be moved were broken down, crated, and sent deeper into the collapsing territory. Those that could not were to be sabotaged. The Black Sun reactor fell into the second category. Its mass, integration into the mountain, and dangerous core materials made evacuation impossible in the time remaining. Plans were drawn up to render it inoperable and seal the facility. In the final months, operations shifted from exploration to preservation and concealment. Sensitive documentation was copied onto microfilm, the originals burned, indexes were altered or destroyed. Crates labeled as machine parts for innocuous projects left the mountain at night, bound for other bunkers, salt mines, or perhaps never-arriving destinations lost in the chaos. The reactor itself underwent a controlled shutdown. Fuel elements were gradually withdrawn from the annular moderator ring, their neutron flux allowed to decay. Some were removed entirely and stored in shielded casks within side tunnels. Others remained in place, rods inserted deeply to guarantee subcriticality. The plasma system was powered down, coils cooled. Residual heat slowly bled into water tanks and out into the mountain, raising the rock temperature by imperceptible fractions of a degree. Then came the deliberate wounding. Access ports were opened along the torus. Key segments of the inner vacuum chamber were cut with torches, warping the precisely machined surfaces, making future vacuum integrity impossible. High-current switchgear was dismantled, copper busbars cut in places difficult to repair. Instrumentation was smashed or stripped for reusable parts in other installations. Explosives were placed selectively. Demolition charges were set to collapse critical sections of the hall roof without completely destroying the rook core, minimizing the risk of scattering radioactive material, yet making rapid reconstruction unfeasible. In ancillary tunnels, pre-drilled blasting holes awaited detonation to bring down entire galleries. In April 1945, the front approached southern Germany in earnest. Rumors spread through the mountain complex of nearby towns changing hands, of columns moving through the valleys. Evacuation orders intensified. Trucks and staff cars lined the forest roads at night, then vanished by dawn. At some point in those final days, the exact date varies by account, the charges were fired. Deep under the Bavarian Alps, in the chamber where the Black Sun emblem was painted, beneath the torus, the floor shook with the sharp concussion of shaped blasts. Concrete overhead cracked, steel trusses bent, dust fell in thick clouds. Sections of ceiling gave way, burying control panels under slabs of crushed rock. The outer layers of the reactor's shielding collapsed inward, entombing the torus in a shell of concrete and steel fragments. Further along the access tunnels, other charges detonated. Entrances collapsed in controlled avalanches of rock and earth. Ventilation shafts choked with rubble. Only a few passages remained passable, known only to those who had wired the charges, and even these were unstable. In the confusion of the Reich's final weeks, maps and memories scattered. When American units later advanced into the region and secured Obersalzberg, and surrounding sites, they found traces of underground construction. Bunkers, storage galleries, conference rooms, and air raid shelters revealed themselves behind camouflaged doors and overgrown trenches. Some worked shafts led deeper into the slopes, but many terminators had been neatly, professionally blown. Technical teams from the US and Britain, conducting surveys under programs that would later be grouped under Operation Harborage and similar intelligence efforts, descended into the accessible tunnels. They catalogued machinery, documents, prototypes, and weapon stocks. In some places, they found evidence of advanced research. In others, just hurried abandonment. References to a mountain power project appeared in scattered papers, but without complete coordinates or intact infrastructure, the investigators could not correlate them to a single site. A few locals spoke of trucks heading up certain forest roads at night, of forced labor columns, of distant explosions. The mountains, however, kept their interior geometry silent. In the years immediately after the war, attention shifted to more tangible spoils. German reactor components, centrifuges, uranium stores, and scientists were captured and folded into Allied programs. The Heisenberg Group's reactor experiments at Haigerloch became a well-documented case study. In contrast, the deeper, more obscure SS projects remained partially hidden behind missing files and sealed tunnels. It was in archival fragments that the Black Sun reactor re-emerged, quietly, decades later. Declassified SHAFE technical reports, dusty microfilms in national archives, and scattered Ahnenerbe files contained mentions of Sonnenrad experiments, toroidal reactor designs, and anomalous field measurements in an alpine facility. The documents were incomplete, pages missing, diagrams separated from their legends. But patterns became visible to those who studied them closely. Cross-referencing personnel lists revealed names of engineers known to have worked on both conventional nuclear projects and plasma physics. Some of these men later appeared in Western or Soviet research institutes, their wartime work summarized only as high-voltage systems or power engineering. Interviews conducted in the 1960s with surviving scientists skirted the topic with vague references to SS interference and unusual reactor geometries that had gone nowhere as the war ended. Geological surveys carried out for civilian infrastructure in the Bavarian Alps occasionally noted anomalous zones of higher than expected residual radioactivity deep within otherwise unremarkable rock strata. The levels were low, far below concern for public safety, but enough to raise a question: had something been buried there that still left a faint signature? In remote valleys, hikers and speleologists in the 1970s and 1980s rediscovered collapsed adits and partially flooded tunnels, some bearing rusted remnants of wartime construction. In at least one such tunnel, explorers reported reaching a concrete bulkhead marked by a faded, circular pattern, barely visible under algae and mineral deposits. Its contours resembled a sunwheel. Behind it, geophones detected a large hollow volume, but further penetration was deemed too dangerous due to instability. The opening was resealed. Modern physics, with its more developed understanding of plasma confinement and fusion devices, has examined the surviving descriptions of the Black Sun reactor with a mix of skepticism and reluctant recognition. The toroidal vacuum vessel, layered coils, and plasma ring echo concepts later pursued in tokamak and stellarator programs. The idea of coupling a fission heat source to a high-energy plasma system appears, in hindsight, both impractical and visionary, anticipating hybrid designs by decades. Yet the wartime implementation, limited by materials, knowledge, and the pressures of conflict, could never have reached the efficiencies of post-war machines. Confinement times would have been short, instabilities rampant, diagnostics crude. The anomalies reported, magnetic interference, cosmic ray modulation, physiological discomfort, likely reflected strong, but uncontrolled fields, operating near the edge of what 1940s metallurgy and insulation could endure. Whether the Black Sun achieved any stable operating regime capable of practical application remains uncertain. No surviving document records a successful demonstration of weaponized field effects, propulsion, or large-scale power delivery beyond the underground complex itself. Most evidence points to an advanced hazardous experiment whose full potential, if any, remained unrealized before demolition. Still, certain data provoke curiosity. The cosmic ray readings, the Schumann resonance experiments, the reports of instrumentation behavior outside the reactor hall hint at interactions between the machine and larger field structures. In an era when the global electric circuit and magnetosphere were barely understood, SS-backed engineers were unknowingly probing the edges of such phenomena with a device built under a mountain, marked by a symbol from a castle in Westphalia. What endures now are traces, residual radioactivity, decaying into background, rusting bracings, hidden behind collapsed rock, deformed steel segments that once shaped a vacuum chamber. Microfilm records in temperature-controlled vaults showing coil schematics drawn in ink that has turned brown, and the recurring emblem, the Black Sun, appearing on floor plans, letterheads, and the concrete plinth beneath a reactor that may still sit entombed in darkness. Deep under the Bavarian Alps, the tunnels that led to the reactor hall have long since settled. Water seeps through hairline cracks, dripping onto slabs of fallen concrete forming shallow pools that reflect only the faint light of occasional maintenance lamps far away. In the collapsed main chamber, air lies still around the buried torus, its surface is cooled to the steady temperature of the surrounding rock. Dust layered over dust has settled on concrete and steel that no human has touched in generations. Above, forests have regrown where camouflage netting once hung. Snow lies each winter on slopes that once concealed truck movements and guarded entrances. Paths used by guards and labor columns have softened into indistinct tracks under leaves and moss. The Black Sun emblem painted on the plinth, if it still exists, lies in darkness. The paint may have cracked, flaked, or been ground to dust under fallen debris, or fragments of its matte black arcs may remain preserved in air too still to carry them away. No clock measures the time in that buried hall now. No coils hum. No plasma ring draws its circle of light. Only the idea persists, reconstructed from files, memories, and the traces science can still perceive, that in 1944, beneath the Bavarian Alps, men assembled a machine unlike the others fielded by their regime. Not merely a reactor for power or material production, but a hybrid device tuned to the resonance of fields, the rotation of ions, the hidden structure of forces tying earth, sky, and matter together. Its operation ended in rubble and silence. Its components, if they remain, are fused to the mountain that once concealed them. In reports and testimonies, the reactor is a cluster of images and numbers, coil currents, neutron, flux, plasma temperatures, the brightness of a toroidal glow seen through dark glass. In the landscape, it is a void, a sealed hollow behind rock, a slight anomaly in the readings of a sensitive instrument carried over the ground above. The tunnels that carried the cables and footsteps now carry only water and air. The chamber that held the black sun reactor is dark, its volume defined only by stone and the memory of lines once drawn on engineering blueprints. Somewhere in that hidden space, perhaps, rests a fragment of the painted emblem on the floor, curve of black against grey concrete, untouched by light since the last lamp flickered and died. And in that unlit circle, beneath the Bavarian Alps, the story of the black sun, Reactor remains suspended, not in fantasy, but in a quiet, unresolved chapter of wartime engineering, a sealed geometry of steel and concrete, a buried machine beneath, the mountains, and a symbol fading slowly into the darkness that covers it.